There's a planet out there that broke science. Not in a metaphorical way, not in a clickbait headline way. Literally, a planet was discovered in 2025 that our best models of the universe said flat out could not exist. And yet, there it is, sitting in space, orbiting a star, completely unbothered by everything we thought we knew. Its name is TOI 6894b, and the more you learn about it, the more you start to wonder whether we actually understand how the universe works at all. Let's get into it. To understand why this planet is such a big deal, you first need to understand the rule it broke. For decades, astronomers have been building a detailed theory of how planets form. It's called core accretion. The basic idea is this. When a new star is born, it's surrounded by a spinning disk of gas and dust. Over time, tiny particles in that disk start clumping together. Small grains become pebbles, pebbles become rocks, rocks become bigger rocks, and eventually you end up with a solid core floating inside that disk. If that core gets big enough, we're talking roughly 10 times the mass of Earth, something dramatic happens. Gravity takes over completely. The core starts pulling in enormous amounts of gas from the surrounding disk and growing at an explosive rate. That's how you get the giants, Jupiter, Saturn, worlds so massive they dwarf everything else in the solar system. Here's the key detail though. This whole process requires a lot of raw material, a big rich disk full of dust, rock, and heavy elements. And the size of that disk is directly tied to the size of the star at the center of it. Bigger star, bigger disk, more material, more chances to build a giant planet. Smaller star, smaller disk, less material. And according to every simulation astronomers have ever run, zero chance of forming a gas giant. That's not a rough guideline. That's not an approximation. Scientists looked at the smallest stars in the galaxy, a type called red dwarfs, ran the numbers, built the models, and concluded these stars cannot produce giant planets. The disk around them is simply too thin, too small, too poor in the ingredients you need. That was the rule. Then TOI 6894b showed up and just completely ignored it. Here's what this planet actually is. TOI 6894b is a gas giant. It's slightly larger than Saturn in volume, though it only weighs about half as much, which tells you it's an incredibly puffy, low-density world. If you can somehow place it next to our own solar system's giants, it wouldn't look out of place. But its star? Its star is tiny. TOI 6894, that's the star, is a red dwarf with just 20% of the Sun's mass. Let that sink in. Our Sun is already not huge by cosmic standards. Now take a fifth of it. That's the star this planet chose to orbit. TOI 6894 is now the smallest star ever confirmed to host a transiting gas giant. Its radius is 40% smaller than the previous record holder. It didn't just break the record, it shattered it. The planet lives about 240 light-years away from us, in the constellation Leo. It zips around its star once every 3.5 days. A year on this world is shorter than a long weekend. And despite sitting that close to its star, the planet is surprisingly cold for a gas giant, hovering around 420 Kelvin, which is roughly 147 degrees Celsius. Warm enough to be interesting, but nowhere near the 1,000 to 2,000 Kelvin temperatures you see on most of the gas giants we've found. Scientists found it using NASA's TESS satellite, the Transiting Exoplanet Survey Satellite, which watches stars for the telltale dimming that happens when a planet crosses in front of them. One researcher, Dr. Edward Bryant from University College London, was manually combing through data from over 91,000 red dwarf stars, specifically looking for giant planets that shouldn't be there. He found one. They then confirmed it using the Very Large Telescope in Chile, one of the most powerful ground-based observatories on Earth. The signal was, as they put it, unambiguous. The only possible explanation? This tiny star hosts a Saturn-sized planet, and nobody can fully explain how. Now here's where it gets really interesting, because the scientific community didn't just shrug and move on. This discovery sent researchers scrambling because it forces a genuine reckoning with our models. If core accretion can't explain TOI 6894b, then what can? Two ideas have been floated. The first is a modified version of core accretion, a kind of middle path where a protoplanet builds up and slowly accumulates gas over a much longer timescale without ever triggering that runaway growth phase. It's a more gradual process, gentler. It might work, but the numbers still don't fully add up for a star this small. The second idea is something called gravitational disk instability. Picture the disk of gas and dust around a young star becoming so massive and so unstable that it essentially collapses on itself in certain regions, forming a planet directly. No rocky core required, no slow buildup, just gravity doing something dramatic and sudden. Both ideas are plausible in general, but here's the thing that keeps astronomers up at night. Neither theory completely explains TOI 6894b. Not fully, not cleanly. The data doesn't fit either model perfectly. Dr. Mathilde Timmermans, one of the researchers on the project, said it plainly, and I'm paraphrasing here. The existence of this planet is hard to reconcile with existing models. None of them can fully explain how it formed. Our understanding is incomplete. That's a scientist telling you, we don't know. And in science, that's not a failure. That's an invitation. Let's zoom out for a second, because the implications here go way beyond one weird planet. Red dwarf stars are the most common type of star in the entire Milky Way. We're not talking about a rare, exotic kind of star. We're talking about the majority. If you randomly pointed at any star in our galaxy, odds are it's a red dwarf. There are hundreds of billions of them. For a long time, the assumption was that giant planets were basically off the table for these stars. Too dim, too limited in raw material. But if TOI 6894b is real, and it is, then that assumption is gone. If even one red dwarf this small can host a gas giant, maybe others can too. And if this type of planet formation is even slightly more common than we thought, then suddenly our picture of the Milky Way changes dramatically. There could be enormous numbers of gas giants we've never accounted for, orbiting dim little stars all across the galaxy. Professor Jamila Chokwar, part of the Discovery team, put it this way. Stars like TOI 6894 are the most common type in the Milky Way. So this discovery suggests there may be far more giant planets out there than we ever thought. One planet, one discovery, and it potentially reshapes our understanding of the entire galaxy. Now let's talk about what happens next, because scientists aren't done with TOI 6894b, not by a long shot. The James Webb Space Telescope, the most powerful space observatory ever launched, has already been scheduled to observe this planet. And researchers are genuinely excited about what it might reveal, because this planet's atmosphere could be unlike anything we've studied before. Here's why. Most gas giants we've found are what astronomers call hot Jupiters, scorchingly hot worlds that orbit incredibly close to their stars. Their atmospheres are dominated by water vapor, carbon dioxide, and various metals getting blasted apart by intense heat. TOI 6894b is different. Its relatively low temperature means the chemistry in its atmosphere should follow completely different rules. Scientists expect it to be dominated by methane. And here's what's wild about that. We have never in the history of exoplanet research confirmed methane as the dominant atmospheric gas on any exoplanet. This could be the first. Even more remarkably, there's a possibility, not confirmed but genuinely on the table, that this planet's atmosphere could contain ammonia. And that would be a first too. Detecting ammonia in an exoplanet's atmosphere has never been done. If Webb finds it here, it opens up an entirely new category of planetary atmosphere that we've never explored. One researcher described TOI 6894b as potentially a benchmark exoplanet for studying methane-dominated atmospheres, and the best laboratory we have for examining carbon, nitrogen, and oxygen chemistry outside our own solar system. Think about that. We didn't just find a weird planet. We may have found the single best classroom in the known universe for studying a type of atmosphere that has never been properly characterized before. Let's bring this back down to Earth for a moment, because I think there's something deeper here than just a cool discovery. Science runs on models. We build these elaborate frameworks to explain how the universe works, how planets form, how stars behave, how galaxies evolve, and those models are incredibly powerful. They let us predict things. They let us build technology. They let us send spacecraft to the edges of the solar system. But every now and then, the universe just doesn't care about the model. Something shows up that the model said was impossible, and in that moment, you have a choice. You can double down on the model, or you can listen to the universe. TOI 6894b is the universe talking. It's saying, your framework for understanding planet formation around small stars is incomplete. You got too comfortable with your own conclusions. That's not embarrassing. That's science working exactly the way it's supposed to. The model was the best we had. Now we have evidence that demands a better one. And that process, that cycle of discovery and revision, is how we've learned everything we know about the cosmos. Every time we thought we had the universe figured out, it handed us something like this: a planet that shouldn't exist, a discovery that forces us back to the drawing board. And every time that happens, we end up understanding far more than we did before. One tiny star, 240 light-years away, with a planet roughly the size of Saturn wrapped around it. A planet that by every rule we'd written had no right to be there. Found by a researcher scanning through data from 91,000 stars, looking for exactly this kind of impossibility. The James Webb Telescope is already pointed its way. Within the next year or two, we may have the first detailed picture of its atmosphere. We may detect methane. We may detect ammonia. We may get our first real clue about how this thing actually formed. Or we may get more questions than answers, which honestly is just as exciting. Because that's the thing about space. The more we look, the more the universe refuses to fit neatly into the boxes we build for it. There are no impossible planets, only planets we haven't found yet. And out there in the dark, circling a tiny dim star in the constellation Leo, TOI 6894b is waiting for us to figure it out. The planet that shouldn't exist does exist.